for now, obviously off to this session, so we've got Nate Walck from Facebook, and over to Nate.
So today we're going to talk about managing OS X with Chef. This is something that Facebook has been on for, it's about a year now? Year and a half. So we're just, it was a little bit, we've been slowly migrating everything over. Mike did all that work in like, what was it, like 3 months, 2 months? 2 months. And then, and ever since then we've just been refining and making it better and improving Chef. So what is Chef? It's not this chef, and no, it's not this chef either. So if it isn't either of these chefs, which chef are we talking about? So this is what Chef themselves say. Chef is a powerful automation platform that transforms complex infrastructure into code, bringing your Macs and services to life. So what does that really mean to us? So peer-reviewable code is extremely important, especially in a team environment. So that's if you have more than one person. If you work on a team and changes are not peer-reviewed, you'll either have a higher error rate or a larger chance of failure, or both more often than not. Having to rewrite code is terrible. So say you have code you have one place, you're like, oh, just copy paste it over somewhere else. That is just, it's setting up technical debt, and it's a trap, really. So say you find a bug, you have to change it everywhere you copied it to in the past. So if you've copied it 4 times, it's 4 places. If it's 10 times, it's 10 places. And it's just drudgery, it's just terrible. So don't get stuck in that trap. And being able to split out common functionality is a large part of object-oriented programming in general. And as a result, it's also part of Chef as a whole. Chef allows you to meet your exact needs. You're not bound to a rigid framework or DSL. It allows you to do everything in a very specific way. I've seen Chef do everything from simple configurations to handling File Vault 2 key rotation and escrow and validation, all automatic, and also 802.1x cert, issuance and renewal. Because of how flexible Chef is, it allows you to move quickly and get things done. It is impossible to make non-trivial changes. It is possible to make non-trivial changes to your client fleet in a trivial amount of time. A whole talk could be done on the Chef run. So if you're interested in exactly what happens during a Chef run, check out these slides here. This is actually a graphic I borrowed, but it goes through everything in detail. So if you really want to know the nitty-gritty, that's a great place to look at it. So how does Chef interact with OS X specifically? Chef is an abstraction layer that sits on top of all the OS X commands that we are familiar with. Chef's main purpose is to abstract and standardize how we interact with it. So instead of like having a list of commands you run, you just tell it what state you want it to be in. So you want this user with this password, and it does it. So you don't need to know actually which commands are being run and which options to use, which command line flags. The resource knows how to handle that for you. And they are implemented via providers. So you have a provider that knows when you specify this resource, these commands are run in this fashion, and it gives you the end result that you want. So there's a ton of stuff we could possibly talk about, but a whole conference could be dedicated to Chef in and of itself, and it is. So if you're interested in that, there's Chef Conf in Austin this year. So let's focus on the things that are important to us for this talk specifically. So it's all Ruby, and literally everything about Chef is Ruby. All attributes, functions, and recipes are Ruby, and the resources are all Ruby-based. You can use Ruby to iterate node objects and take action based upon data within the node. You can dynamically change settings based upon data that's in the node. And the customization possibilities are endless. You can do anything you really need to do. As a result, you can do very simple and straightforward configs, like adding a user, or you can do insanely complex code, which can get hairy, so be careful and make sure you're writing it in a sustainable fashion if you choose to do that. So some of the core components of Chef are roles and run lists. Role is the item that contains a run list. It allows you to point your client and say, this client is this role. So a good example is you'll have a role called desktop or a role called laptop. And that changes what it gets applied to the client based upon what's in the role. So what is a run list exactly? A run list is somewhat self-descriptive. It is a list of recipes that do what you want your node to run. So it's a list of recipes that accomplish the end state. So create these users, load these services, place these files. Let's look at a simple role. This role has a name, description, and run list. You tell a client that this is the role to use, and it will run all the recipes that are on the run list listed in there. In this case, we're adding custom OHI plugins, which is how you gather data about a node. And we're also running something called chef init, which is a recipe that includes other recipes. So it's dynamic, essentially. It allows you to have one place that you can scope things and tell it how to do what it needs to do. Chef init works by building an array of recipe names. As you can see here, we are adding 3 recipes to the run list array: user accounts, screensaver, and SSH. We can do some basic scoping in chef init as well. For instance, say you have a certain user that you always want to have a specific recipe. You could say, if the current user is Nate, then give them some really annoying settings, because you just don't really like that user. It's always nice to know what is going on. So chef init ends by logging out a list of all the recipes applied, so you're never in the dark about what's going on with your node. And then it also includes the recipes, so the node processes and applies them. I mentioned Chef uses cookbooks, but what specifically is their function? Cookbooks can contain any of the major pieces that Chef uses during a Chef run. It can contain recipes, attribute files, templates, and files themselves, so just whole files. Cookbooks can use the default file for each type of resource. So let's look at an example of this. This is the general structure of a cookbook. It is simplified for this example, but it gives you an idea of what you can have in a cookbook and what the structure would look like. The sample cookbook is a directory, and then everything that doesn't have a file extension is also a directory. So you have attributes with the default file in it, files with another directory called default inside of it. So if the default attributes file exists, it gets used by default. That's why it's named that way. So if you are using this, if there's a file called default, it will get used every time. This is where you would set same defaults for core management cookbooks, such as, say, screensaver or security and privacy settings, something you want across your whole fleet as a standard for the fleet. When looking for files or templates, the cookbook will automatically look inside the default directory for the referenced item. So this is the default directory. Say you have SSHD and it's a file. It would be inside the default directory, and it would automatically find it there, because it's a place that it would search for it. For recipes, if you include a cookbook and the default recipe, it uses whatever is in the default recipe file for that cookbook. So when you include sample cookbook here, it would automatically run whatever is in default.rb, just by the virtue of including it. So the recipe is essentially some of the active code that gets run when you include it. So from the default RB, you can either do all the work you want to do in the entire cookbook and specify which resources, like files or users or services you want, or you can include other recipes as well from within the recipes folder. Metadata.rb is an important file as it has basic information about the cookbook, such as any dependencies the cookbook has, among other information such as author, version, README, and other things of that nature. There's a ton more you can do inside cookbooks, so if you're interested in knowing all the details on that, go to learn.chef.io. And they cover everything. They have regular documentation, they have tutorials, they have a little bit of everything there. So you can dig into one topic at a time if you want and learn one piece and go, learn as you go. So let's dig into attributes a little bit. Attributes are specific information about your node or your machine. There's a default set of attributes that are gathered by OHI at runtime. Attribute information can vary from how much memory the node has to what the screensaver timeout should be for the machine. Attributes are data objects. They can be hashes, arrays, They can be straight up values as well. How the attributes are constructed act as a namespace for that data. And I'll explain a little bit more on what namespacing the data kind of looks like. This data is typically stored in the node object, which makes it available to the recipe at runtime. So anything in the recipe, when you're running stuff in your recipe, any data that is known about the node, it has access to. So you can say, give me the memory of the node. You can say, give me the current user. Give me, basically any information you can get from System Profiler, you can pretty much get in there. So the node is your machine, and it contains other information as well, not just hardware information. So you can have derived information, and like you can say, is this machine Windows or something of that nature? And it'll tell you true or false. And I'll get back to that as well. So let's take a look at what this looks like exactly. We're going to use Chef Shell here, which Chef Shell is essentially, if you use Ruby and you're familiar with IRB, it's interactive Ruby. If you're familiar with Python, it's like interactive Python, just running the Python command and typing some stuff out and seeing how it goes. Or if you're, even Bash, it's like opening terminal and running commands. So when we run this command here, it prints all the keys of the node object. So any information that exists in node, it will show you the name of that information, so it's the key for it. So when we run this, it looks like this. Well, this is a lot of information, and we don't really need all of this, so let's just pick one out and take a look at it. Each item here is a key. It could contain data, as in just like a string back, or it could contain another array or hash of information. It depends really how the data is structured. They're typically not just key value pairs, they're typically nested hashes, and it all ties into that namespacing like I mentioned before. So let's take a look at how this works in practice. We'll take memory, and we will look at the keys that memory has. So within memory, we have the keys total, active, inactive, free. Well, let's take a look at one of those. Let's go with total memory. So we're going to print the value of memory, node memory total. So we're going to print that out and see what we get. As you can see, this node has 16 gigs of memory. The namespacing of this value tells us everything we need to know about it. It is the total memory for the node. What about host names? Probably not a hash, as that wouldn't make a ton of sense, although I know there are multiple host names on this thing. So when we print that out, it's Nate-MBP. So that's the name of my laptop. So what about node functions? Here's an example. It's a pretty simple example of a node function that could be useful in your environment. It uses node attributes to determine if the platform is OS 10 or not, and then it returns true or false depending on what the node attribute says the machine is. So node platform is always a unique identifier for the OS it is running. And also note, it has a question at the end. This is kind of a Ruby-ism, if you will. You'll have to adjust for your own regional dialect, but the way Mike and I like to discuss it is, we say, Mac OS 10, as if it's a question. And this is how you refer to the function whenever you're using it in your recipes. So we're back to Chef Shell here. We're going to print node OS 10. It's like talking to your node. Node, are you running OS 10? Yes, I am. Here's another one. Are you running at least OS 10.9? Are you greater than 10.9? The answer is, well, yes, I am greater than 10.9. Now keep in mind, this could be 10.9.1, because that is greater than 10.9, or it could be 10.10 or 10.11 or what have you. Say we want more specificity. We can check and say, are you at least 10.10.3? And if it's 10.10.3 or greater, it will return true. In this case, my node has told me, indeed, I am 10.10.3 or greater. This is extremely helpful for scoping your configs and your recipes, because sometimes Apple will update stuff in a reversing compatible fashion, and it causes lots of pain and suffering. So it's super helpful to be able to scope things out and say, if it's this version or less, use the old way, and if it's newer than this version, use the new way. In a cookbook, you can set the defaults in the attributes file. Then later in a run, you can override this default in another recipe. This allows you to set same default settings and then override them later if desired for a given user or a specific use case or a department or a computer lab or what have you. It is important to remember that whatever sets the attribute last wins. It's just like redeclaring a variable over and over, and whatever sets it last is the actual value that the variable contains. So let's take a look at this. This is like bash here. So we're just going to set timeout to a value of 1, and then we're going to do some other stuff, and then later we'll set it to a timeout of 42. So you would expect that timeout would be 42, so let's take a look. And indeed it is 42, because that was what it was set to just before we ran the echo on the variable. It's exactly the same way in recipes. If you set the value in your attributes to 1, and then later in the recipe you set it to 42, when you go to use it, it will actually be 42. And the reason for this is, as I said, you can set defaults and then override them later as necessary based upon whatever scoping you want to. And because it's Ruby, you can tie into any internal service you have, any API, anything at all, and use that to make decisions on what configs get applied to the machine. Generally, we try to keep it local, but you can literally do anything. Doesn't mean it's a good idea, but you can do it. So recipes use all the data available in the node object, along with resources and Ruby logic to get things done, so to apply configs in general. What can you use? Resources are what tell Chef how you expect a certain thing to be configured. For instance, if it's a user resource, it would create a user with the specified settings. If it's a file resource, it would populate the file as you specify it in the resource block. If the resource already exists in this state that you've set, it just skips it because it's already where it needs to be. This is typically called being idempotent. Additionally, because a recipe is actually Ruby, you can set variables, access the node object, and iterate complex data sets if you want, all right there in the recipe, just to apply resources and make decisions on what you need to do. Another key concept in recipes is using the attributes to decide if something should be applied to the node or not. Any logic available in Ruby is available in the recipe. You can do if statements, you can do unless, you can do case. Anything that's available in Ruby is available in the recipe. Recipes can be as simple as setting one attribute for a node to override the default, or as complex as iterating a data set, as I mentioned, and applying a resource for each item within that data set. So if you have a vast array and you want to create like 5 different services, you could put them all in there, iterate it, and then your code's much shorter, because instead of doing it 5 times, you just do it once with the resource and once with the array and list them individually. So let's look at resources. There are special functions that you use in your recipes to make changes to your node. Chef has all the usual suspects. It can manage files, create users, start services, etc. This resource creates a local admin user. It's basically what creating users looks like in almost every config management system. You have to give it the name, you have to give it the full name on OS X, so it's pretty, the home, the shell, all that stuff. You almost can't get away from putting those things in there. So it's essentially how it looks everywhere. So that's extremely boring. So let's just do a stupid chef trick, if you'll indulge me. So we're going to make 100 users, and they're going to be user 1 through 100, because why not? So this literally will iterate 100 times, apply that resource block once for each number, and you can see I'm setting user run number. So the first run number will be user 1, the second run number will be user 2, and so on, all the way to 100. So I did this on my test VM, and it was really exciting at the login window if you didn't have username and password enabled. Yeah. Scroll a while to find my account. Chef's default package provider is actually Brew. So Mike wrote a provider that does OS X packages. It installs them from a remote HTTPS server by default, but it can also install packages from a local location as well. So if you dump the package onto a local file path, you can install it from there if you'd like. Remote package needs to know which server to use. So in our cookbook called Remote Package, or sorry, OS query, that's the actual cookbook name there, we will add the server to the default attributes file. And it's just like I was saying earlier, when you set stuff in the default attributes file, it's setting sane defaults. So this server here, anywhere remote package is used, it will use this server's value. So you don't ever need to redefine this again. You don't have to redefine it in every cookbook you use, none of that. Just once in one cookbook, and that's all you have to do. So here's the actual resource. You feed it the package name, the version, a checksum, and a receipt. And what it does is it constructs the name of the package from that. It'll say, okay, we're going to take OS query dash version number, look for it on the server that we defined over here, and if it exists, it will pull it down, make sure the checksum matches what you have here, and make sure that the receipt is not present. If the receipt's not present, it installs it because it's not installed. If it is present, it moves on and skips it because it assumes it's there. Now, I will say, I would not do packages with config management a whole lot. This is kind of for one-offs. If you need to do packages of any sort, I would use Monkey for basically everything. This is normally to install Monkey so Monkey can do everything else for us. Enabling a service is dead easy. You use the label as the service name and tell it to enable or disable, and that's all you do. It will look on disk for that name, so com.company.autopackage.plist, and it'll look in library launch daemons and library launch agents, and if it's there, it will load it for you. And it's worth pointing out for services, if you don't own the service, if it's something like, if it's something that ships with OS 10, this is a great way to do it. But if you're placing a service, don't do it this way. There's actually a much better way to do it. Also, sometimes the labels don't match what's on disk, like SSH and Kerberos and some others. So you must specify the path to the plist you actually want it to load. That way, finding it by label is kind of magical, but magic doesn't always work out well. So if that's the case, feed it the plist and it can still do its thing. So there's some cool stuff here. So while these common resource types are all useful, there are some OS 10 specific resources that make Chef, in our opinion, the best config management tool for OS 10 at the moment. For instance, there's a new LaunchD provider that was also made by Mike. This LaunchD provider generates the services plist file for you, so you don't have to hand edit plists or do any of that nonsense. You don't have to create it and then deliver it to the location and then load it and have to remember all that stuff. That's just, ain't nobody got time for that. Not to mention, you shouldn't repeat yourself, right? Most importantly, it provides all the LaunchD keys as documented by Apple. So if you do man launchd.plist, all the keys that are there are available in the provider. This is what it looks like. You specify the label for the resource name, the program to run, so typically that's a binary or script or what have you, and then whatever additional options you want. So this is the 7th day, 10th hour, timeout, so if it's longer than 5 minutes, LaunchD will kill it for you. So this resource, as you see it, will write the plist for you. So what's that? You want to not only generate it, but you want to load it as well? Sure, no problem. You just add that one line, action enable, so you see, one line, literally, and it does it. So it'll lay it down, load it for you. And then as an added bonus, if you ever change this in the future, if you just change timeout to 301, for instance, it will lay it down, unload it, reload it for you. Dead easy. So you can also do agents as well. LaunchD does those. You just specify a type of agent, and it'll put it in library launch agents instead of library launch daemons. You can also disable any launch daemon, much like the service provider can. You just pass it the action disable, and it'll try to match the label to a file on disk. And just like with the service resource, you can give it a plist if it doesn't match. Later, you decide it's time to get rid of that service. It didn't work well anyways. So feed LaunchD the label of the resource name and the delete action. It does the right thing. It will unload the launch daemon and then delete it. I don't know if anybody's deleted it before unloading it. Not fun, not fun. There's more as well, and this one's exceptionally cool in my humble opinion because I wrote it. It allows you to install profiles from either a physical file within your cookbook or a Ruby hash. The Ruby hash part is especially exciting because it allows you to do some really cool dynamic profiles. And I'll show you more on that in a little bit. Let's go through the basics first. So say you have com.company.screensaver.mobileconfig. You put that in your cookbook, files, recipe, default directory. You just put it right in there. You specify this one line. It will download it and install it. If you ever change that file in your cookbook, even one character, it will automatically download it again, reinstall the profile because it knows it has changed. So we can do profiles, but what's the point of doing profiles in Chef? Why can't you just install them via bash script or use Monkey, which is a great tool, but decidedly not config management? Well, here's one profile. Say you have a copy of this profile and you just want to change one value, like idle time, right there is 0. So you want to change it to 10 for one person. And this is in Ruby hash format, so it looks a little bit different, but you get the idea. It's the same sort of length. All right, so what about 4 machines? Well, now you have 4 copies. If you ever need to change the org name or the identifier, anything like that, you need to change it in 4 places. What if you have a couple departments? Now you need to change it in 16 different places or potentially more. Well, that's getting out of hand. I don't want to have to change, like if I want just a visual bug to be fixed, I don't want to have to change it in that many places. That would drive me bonkers. So instead of doing this, why don't we dynamically build the profile instead? We could save a lot of repeating ourselves and reduce the chance of failure. So this is a profile in the form of a Ruby hash. Basically, it just means that all the key names and value types are stripped out. And you can see there's payload identifier, com.company.screensaver. That's the standard payload identifier. It's how the system decides whether it's installed yet or not at all. And some other information here like organization, company, that normally doesn't change a whole lot. Maybe if you're required or something like that, change the name for some reason. And then display name is also just the pretty display view in there. So everything that's grayed out is ultimately not that important. So I'm just going to skip over some of that stuff. So here's the payload block. This is the display name in system preferences, normally the gray text. So it'll show you what the payload is, and it'll give you a short description or display name for it. And that's typically what it'll show. And here's the actual content. So here we have com.apple.screensaver, which is the preference domain. And then we have the actual setting, which is being laid down as an MCX preference setting. I believe this was originally created, so this is a little bit circuitous, but this was created using MCX to profile or something like that, and then hand edited to clean it up, and then converted to a Ruby hash. But good tools, so why not use them? So let's say we decide to change the idle time to 300. The provider would know that it's changed and automatically reinstall the profile. Even though it's in the hash, it's not a file in disk, it still knows the contents of the profile, regardless of whether you edit in a Ruby hash like this or as a file in your cookbook. So what if we did this? Let's just point it at an attribute data. So this is an attribute namespace, which I said we were going to show the importance of. So it's the idle time for the screensaver, and it's a preference for the node. So you just read it in reverse order, and it should describe what it is that you're setting, or what it is that you're using in this case. So then, in the attributes file, we define that as 1. So the idle time is now 1 second. It's a good security team friendly default, and that's what we use for a whole fleet. Except this one guy hates it. He doesn't want to be bothered. So if his host name of the node is Nate MBP, the timeout's now 600 seconds, and it uses the exact same profile that we showed earlier. The only difference is the idle time. So my machine gets something different from Mike's machine. So Mike can be annoyed, but I'm happy, but I might get jelloed, so it might be bad. All right, so let's go back to the original example. We can do 4 different settings based upon node data. To add more, simply add like a case statement or if statement or whatever you're most comfortable with. You could just even, say if hostname equals this, setting equals this. If that's what you're comfortable with, perfectly fine. So in this case, you can see we are scoping to department of the node. So we have computer lab, finance, HR, help desk. Each one has their own setting. I'm changing it in one place, just that setting, not the profile. I don't have to have 4 copies of the profile. I have 4 copies of the setting, and that's it. So it's the least amount of work to get the same result. Removing profiles is just as easy as with launch the items. Just specify the profile identifier and the remove action. It's worth noting you do not need the original profile to remove it. So you can even use this to remove profiles that were installed by some other process. All you need is the profile identifier, which you can identify using the profiles command. If you don't know it off the top of your head, which who does? So yeah, this is as easy as it is. You just remove it. Nothing more. So here's a good advanced profile example, which I whipped up, I think, just last week. So let's say you had an unknown number of apps that had let's just say a vulnerable auto-update framework system maybe built into them. So I'm talking about Sparkle. Sparkle is mildly annoying because each app could be in one of 2 states. It could have an ancient Sparkle framework or it could be using an HTTP feed URL. We can be clever about this because we have Ruby at our disposal and can do some checks to see what state the machine is before going ahead and installing resources. So the first thing we need to do is identify which apps are vulnerable. Here, the recipe calls out to a Ruby library that I wrote, which gets a list of app bundle identifiers that contain vulnerable versions of Sparkle and use an HTTP feed URL. So it says get vuln app. That's actually a function that's living elsewhere. I didn't want to get into that because I would have been even further into the weeds. But basically, it's a library that looks at the state of the system, says, okay, which apps have the Sparkle framework? Okay, which apps have an old version? And then which apps have an insecure or unsecure feed URL? And then all it does is return a list of those names. So this is what it looks like. We get Adium, Keka, VLC, a couple things like that. So those are all the apps that meet those requirements. HTTP feed URL, old version of Sparkle. So we have one generic piece of the profile that we want to apply to each of those apps. We don't want to do it globally because there might be some apps that are updated more frequently, and we don't want to punish them for that. So here's a snippet of the profile. What it does is it disables automatic updates, it disables automatic update checks, and it sets the feed URL to a dummy address. It's just localhost. If they've hijacked that, you probably have bigger problems. And this one payload will just disable all those things for you. Okay, so we have that payload, and we have bundle identifiers. Let's put them together. So right here, we're going to iterate that list of bad apps, if you remember, which is the bundle identifiers. And for each bundle identifier, we're taking that hash that disables all the programs and just assign that to the key. So it's, like for instance, it's the VLC one equals, and then that forced snippet from right here. So it will be, let's do adium, com.adiumx.adiumx equals this hash. So if you were to print the key name of that, you would get this back. Then we take the generated payload hash and put it into the profile scaffolding. So I predefined a profile over here. It says disable profile Sparkle hash. See the ellipses? That's basically all the stuff that we went over in the very beginning. It was the display name and the org name and all the generics that you would have to set anyways. So what we're adding to that is only the actual payload. So in a profile, you have all that other information, and then you have the payload. So we're taking a scaffold of the big part of the payload profile, putting the payload inside of it. Now you have a complete profile ready to go. And then we pass it to OS 10 profile, and it installs the profile. If you're curious what this looks like, check that link out. It's from a VM, so I intentionally installed some apps on there, and it will show you. I think there's 3 in there, but you can see generally how it looks and what the iteration did. So you have 3 different payloads, 3 different settings within the payload, one for each of the apps, and it disables everything for that app. The really cool part about this whole thing is, say you update the app using something like Monkey, and it now has a better version of Sparkle, and is now using an HTTPS feed URL. The next time Chef runs, that app will no longer be on the bad apps list because it no longer is, unsecure, and it knows that based upon the criteria. So as a result, it will reinstall the profile. It will no longer disable those 3 things for that app, and that app is now free to function as it would. So essentially, I never have to touch this again until all the apps are updated. If they're bad, they're always going to be bad. I don't have to worry about it. They're disabled. If they're bad and they get updated and they're now good, it just automatically re-enables them for me. I don't have to do anything else. So, the future. The client platform engineering team at Facebook is committed to making Chef the best config management tool for OS X. We have a strong desire to make managing OS X native services specifically as frictionless as possible. We are considering many different areas to improve Chef on OS X, so stay tuned for further developments and announcements. And if you have any questions, feel free to ping us, preferably on Facebook or Messenger, and we'd be happy to talk to you about it. It's something that we're really passionate about, and we will take time out of our day to help you get going. Oh, and since Greg used the QR, I figured that I could. So these are links to some of the things I discussed and some other helpful tools that I used to construct my profiles. We can go to the link at the bottom, good old-fashioned way. So questions? You can save it for later. Or just write down the link. Thanks, Wes.
Okay, so questions. I see one already.
So I'm not as familiar with Chef as Puppet, and I guess, can you tell us a little bit about who owns the technology behind Chef? Is the Chef a company, or is it like an open source community, or what's the deal?
So the Chef model is, it's very open source friendly, and they actually have something, Phil D, who's the chef, basically the head chef guy for the prod side of Facebook, he said there's this, it's a contract with the community, and it outlines how Chef promises to interact with the community when there are issues or improvements or problems within the community. So they have that, and that turns out well. And also, because Phil D is a core contributor, we can write stuff for Chef and get it committed into Chef Core, and anybody can do that, really. You do have to go through standard code review process. But Chef is run, I think they used to be Ops Code, now there's just Chef, right? Yeah, I think there's just Chef now. And it is a company, they do have a paid hosted product, if you want that. But the open source version is the paid version, and that's something they stress. You have the open source version, it's fully functional, it's not gimped in any way. And then you have the cloud version, which just gives you some nice web UI and some continuous integration and a bunch of other stuff. So if you don't have the time to build all that out, you can pay them and they'll help you out with it. So that's their business model. It's kind of more along the lines of, like a Red Hat-ish kind of way, if you're familiar with that.
Next question, straight behind you.
Hi, so what were you using before Chef? Were you using Puppet? And if you were, why did you move from Puppet to Chef?
Yeah, I'd like you to answer that because that's cool.
So I didn't have any Puppet code, but when I was making the transition, I was deciding between Puppet and Chef, coming from running Casper and Monkey internally. When I made the decision, we did it as a team, really, and it was a very core to how we do things. Very much code wins arguments. We started just writing both Puppet and Chef code, and we decided which one we'd like. Before we got this far, too far along, we got instructed by Phil D, oh, you got to do this, and this is great, and it has been, but also it's because we have a lot of internal Chef experts, so that helped us along. But in general, just looking at the Puppet code versus Chef code, I enjoy reading the Chef code better. And there's a few things that I like about Chef, in my opinion, is that it's true Ruby within the recipe block. So you can write functions and just use those. You can do loops and all this kind of stuff, which at the time Puppet didn't have, and they use a DSL, so it's a little differently. And then scale. We have a pretty big fleet. When we first rolled it out, we only had, on the client side, one Chef server, and it just handled it no problem. The difference being that all the computation is done on each client. So as your infrastructure grows, so does your Chef servers. Whereas Puppet, you'll need many masters if you want that type of setup.
Thanks, Mike.
Next question. Anywhere? Really? No questions?
A lot of times I've heard that when the IT department is asked to decide between Puppet or Chef or Ansible or some other
Salt
solution,
stack.
Salt, yeah. The decision is actually made on the development side, especially in tech companies. If they already have Ansible or if they already have Puppet, then there's a lot of momentum for them to do that.
Yeah.
What would you say? Is it worth fighting for Chef in those situations, or is it really a case of just go with the developers?
Yes, I think it's definitely worth fighting for Chef, and obviously we're going to continue improving OS 10 on Chef, or Chef on OS 10, because that's how it works, right? As a result, I think that we're already starting to outpace some of the functionality that's baked into Puppet by far. And the stuff that we're doing is going into core. So that means it's by contract, according to the company and the community contract, they will support the code that we've put in. Even though we wrote it originally, they will support it. Like if we both got hit by a bus or something, they would still support that code. And that's pretty important, I think. It's not just going to die off because the contributor who's external to the company now doesn't want to do that anymore. It's not like that.
Two questions. The first one, have you been able to manage the espresso machines and the coffee machines with Chef?
No, not yet.
No, not yet, okay. Second of all, serious question though. Say I'm new to Max. I can bust out a 10-line bash script and I'm feeling pretty great about myself. From what I've just seen, Ruby's up there, and I'm like, that looks crazy. What is that? What would you recommend as a starting process for someone who's like, this looks really cool, and I want to do that, but I know 5 lines of Bash. Do you have a get started kit? How do you recommend? Because I'm sure there's a ton of people in this room right now that are in that scenario. Some of us are lucky, and we've been coding for a while. But for a newcomer, this looks really aggressive and really hard. Do you have any recommendations for that?
Yeah, that's fair enough. One of the goals that we have for Chef is we want to make core cookbooks. So we want to say, for managing screensaver, for instance, using a profile, there's a limited number of settings you can have for screensaver. So we want to make a cookbook that uses nothing but attributes to set those settings. So what you would do is you would say, okay, I'm going to depend upon the screensaver profile, and then I'm going to set one value. And if that value is set, it will then go ahead and manage screensaver for you. So it would basically be like, if you remember the node line, it said node, screensaver, idle time equals whatever. That's all you would have to write. No Ruby code, just that one line. And eventually, once you get familiar with that, you can dip your toe in a little bit and start doing some more advanced things. Once you're comfortable with that, continue going and iterating on that knowledge. And LearnChef.io. The LearnChef.io is great. They do kind of focus Linux and Windows a little bit because they are, the bigger market shares on the server side. But it's still applicable, all the information about recipes and cookbooks and attributes and all that. But yeah, I would definitely check out that as well.
Thank you. There's a question over here.
Hey. You mentioned Ohio scripts, was it? Ohio?
Yeah, Ohio plugins.
Ohio plugins. Is that a core component of Chef, or is that a general thing? I just haven't heard of OHI before.
Sure. Yeah, I didn't dig into that because that would have been, it was already a little bit in the weeds. Okay, maybe a little while. But anyways, it would have been even more into the weeds. So basically, if you're familiar with the Puppet architecture, there's Puppet and Factor. OHI is Factor. And it basically collects data about the machine and about the current state. So you can do a lot of things in there, like decide what network it's on,
And like Puppet, that's stored in a database on the server, so you can look back at those facts.
So like Monkey, all processing is handled locally. So the client looks at the state of the machine, and then what you've said you want the state to be, and then the client does it all. So instead of having to do everything, like gather all this information, ship it up to the server, let the server decide for you, ship it all back down, and then do it, it happens locally. It just pulls it down once from the server, looks at itself, says, oh, I'm out of compliance, and puts it back in.
But is there maybe logging into the web UI on the server? I'm guessing you might be able to see, like, show me, do a query on some attributes on your fleet.
Absolutely. If you use the website of it, which is hosted, you can also have on-prem, and there's like various different things. The web UI specifically is a paid product. I believe there's some stuff out there to do it on the side, kind of like Puppet Dashboard if you're familiar. But yes, you can absolutely do that. You can ship attributes back. It's not feasible with our fleet, with 10,000 machines, shipping all their information back, 4 times an hour. It's just not great. So you can do it either way, essentially.
Got a question up in the top corner. Again, yeah, just watch that.
Two questions. First one, regarding the attribute for the node, is it possible to load it dynamically from a playlist file or something related to NS user default? For example, if you want to provide the department name via MCX or MDM, for example?
Mm-hmm. So basically loading the data externally?
Yeah.
Yes, you could do that. I think you can do it with OHI to get it into attributes, or you could just do it in the attributes file directly. It depends how you want to do it. We actually do something similar. It's okay? Yeah. Okay, it's okay. All right, so we do something similar where we pull down information about, like, Nate's an employee, Nate's in this location, Nate's part of this department, and we actually include that in the node. So it's like node, I'm gonna make something up, user information, and then I can say node user information department, and it'll return which department I am part of. And then you can scope things based on that. I was kind of alluding to that with like those namespaces, but yeah, you can definitely populate attributes from any source, literally.
Okay, and second question, how do you publish and push the whole receipt and things to the clients? What is it? Is it a web server and?
The Chef server. Yeah. So Chef server is, I don't think it's straight HTTP, is it? Remember. All right. So the Chef server is, you host that on a Linux box or whatever, and they do have a database backend, and they have a really sweet, even for the open source version, you can get high availability. So you can have 2 servers that have a backend that's redundant and all that stuff. So you can get all that, and the way the clients connect back to it is using, it's like a private key system, more like SSH, less like SSL, if that makes sense.
Okay.
Yeah.
Okay, thanks.
Oh, were you asking about updates as well, or?
I'm sorry?
Were you asking about updates as well, like how do you update clients?
Yeah, the whole process about publishing the catalogs and updating it.
Sorry. Go ahead.
Yeah.
Not a good catch that time. All right. So typically the workflow is that the admin writes some code, then uses a module on their workstation or dev machine and says knife. All the Chef terminology is food related. Knife, cookbook or recipe, upload to the server, and then the server now has it and your clients will get it. Facebook and other people do it slightly different, where we check all of our configuration into Git. It goes through our normal peer review workflow, which is Fabricator. Our Chef server runs something that's been open sourced by Facebook, which is called grocery delivery, that basically just does a get pull every minute. or whatever, and then as soon as it sees that, oh, Nate uploaded a new cookbook, it does a knife upload on the server itself. None of us actually have direct knife access to our chef server because we don't need it. We want every change to be peer reviewed, and that's how we get around that.
I like the profile provider. That's really cool. And I was thinking, using that, would you be able to do? I'm guessing the answer is yes, but like dynamic profiles, like Profile Manager lets you do, so like fill in like usernames for like an email profile or an AD binding, enter specific.
Absolutely.
Content.
Yeah.
Okay.
I wanted to make some like dynamic examples, but I ran out of time. And it's kind of complicated because you have like, you know, you go to a profile manager, I was checking all the boxes,
Right.
getting a profile with literally every setting for that one thing, looking at it, saying, okay, what's common, what's not, how can you reduce that down? It was a lot of work.
Yeah, yeah.
So I just went with this instead for now. But yeah, and you can use just a straight file, you could make it there, import it into Chef, and it would work fine. But yeah, you can definitely do it dynamically. It's as well as you can understand the data structures, is as well as you can do it dynamically.
Okay. That's
So,
a
yeah.
big feature.
Yeah, I was just basically going to ask, out of your total management on any client, how much are you defining with Chef, would you say?
2010? Yeah.
There's 1,010 resources that run each time.
Oh, really? You see, I didn't even actually know that number off the top. I knew it was under a minute. It was under 40 seconds even. Yeah. Yeah, we have a lot of resources on there right now. Because it's all client-side, it doesn't balloon nearly as quickly as when you have to do server-side processing and
So-
get it back.
So it's doing actually quite a lot, and the only things that it's excluding really are some package delivery, is that?
Yeah, we use some packages, but like I really hate it, so we get to fight sometimes about it. Because I'm just like, no, use Monkey. Just don't do it. If it has a UI, don't even think about it. But yes, you can do it, and people do it. I dislike it personally, but that's just a personal quibble. Yeah.
Yeah, just come back to that approach. I love your profiles. It's a wonderful thing to do. So basically, for the workflow, you go to Profile Manager, you download the XML, you say it's too long, I don't need that. You just load it up, and then more or less like first approach, flat file. Okay, but then dynamically, next approach, what can I use with dynamics in the cookbooks? And so you refine your profiles step to step, or how would you say would the workflow?
Oh, you mean going from like a file to a hash?
Yeah.
So on one of these links here, if you can get to it, is something I made called Ruby. It's config to Ruby hash, I think it is. It's a Ruby script. You feed it a mobile config, and it spits out a formatted Ruby hash, and you can just copy paste it over to wherever. I think Mike found an edge case on it. So be careful about the formatting on it. I need to look at it and figure out how to fix that bit. But yeah, basically you just want to confirm that it doesn't add extra junk to it. Because there's some differences between pless and Ruby hashes. But yeah, there's definitely a tool for doing that. It'll save a lot of legwork. Because I tried doing it manually a couple times and it was miserable. So I just wrote something to do it for me.
Okay, I think we're pretty much out of time, unfortunately. So I guess you're still here for the rest of the day.
Yes.
Cool. So
Definitely.
we'll find it in the blue shirt.